Okay, this video is going to be for lesson 8.5, solving rational equations. But first I want to put the answers up for you from yesterday's assignment so you can see them. So if Mrs. Wiskevich will start this video and then stop it so you guys can see these questions here, these answers here for a moment. And we'll leave them up and just for a second. And so there's the numbers 11 through 16, and here's the rest of them. So you take a look at those problems, and I will go ahead and do a couple of them for you on the next page so that you can at least see them one more time. All right, so I'm going to do, I think we'll do number 14 and, let's see. I guess we'll do 12 and 14 then, or let's go 13 and 14. 13 and 14. Okay. All right. So numbers 33 through 38 says identify all the zeros, asymptotes, and holes in the graph. Does not say you need to graph it, so you don't need graphs for them. But I'm going to do 13 and 14 because those are ones that you have to graph also. So let's get those for it. So here's number 13, which says identify all the asymptotes of each function, or zeros and asymptotes. And number 14 says to identify the holes and then graph. All right, so let's get our graph up here before we get started. Okay, so in this problem, we want to find all of the zeros and the asymptotes that are in this for this function. And first of all, we would factor, if there's any factoring we could do. In this case, there isn't. So we have to solve the numerator. So to find the zeros, we let the numerator equal 0. So 5x plus 2 equals 0. And we subtract 2 and divide by 5, so we get x equals negative 2/5. So negative 2/5 would be our 0. And we have a vertical asymptote when the denominator is equal to 0. So when x plus 1 is equal to 0, and that would be at negative 1. So reminder, it is a line. You must say x equals negative 1. You can't just put negative 1. And for the horizontal asymptote, we look at end behavior. And so for this part, we're going to focus on just the leading terms, or the terms of the highest degree, which would be x over x, or 5x over x. And this simplifies to 5. So our horizontal asymptote would just be y equals 5. So for graphing this, we're going to first of all graph our 0, which is at negative 2/5. So we'll put a 0 here. And we have vertical asymptote x equals negative 1. So that's a vertical line. And so x equals negative 1, that would be right here. And then we have a horizontal asymptote at y equals 5. And so that is right here. Okay. So now I pretty much know that this graph then is going to be up here and here because of the 0 we have. And the only other question might be is where is the y-intercept? And that's the only other thing that's going to make a difference. So for the finding the y-intercept, we let the x is equal 0, so we get 2 over 1 is 2, so we have the y-intercept of 2. So this graph then is going to start here, go up, and go that way. And then up here in this corner of where our asymptotes are, the graph will go there. And so there's our graph for number 13. 0 is -2/5, vertical asymptote -1, and horizontal asymptote at y equals 5. So let's go ahead and look at number 14. Number 14, very similar to number 15, or number 13, except for in this case, they say, okay, there's also a hole in the graph. So we need to recognize the hole in here. So let's just do what we did with the last one. And the first thing we're always going to do is look to see if we can factor it. And so the numerator, I can factor that. That's x minus 2 and x minus 3. And the denominator, we have x minus 3 and x minus 1. So, zeros. There's a 0 at 2, 3. Vertical asymptote at x equals 3 and 1. Now, the only problem is here is that we have a 0 and a vertical asymptote at the same spot, and that can't happen. And so because we have a common factor in the numerator and the denominator, that means that instead of there being an asymptote and a 0, there's actually going to be a hole there. So there is a hole at 3. And here we have a horizontal asymptote at y equals 1, because we have x squared over x squared, the highest degree term in both the numerator and denominator, just simplify to 1. So let's put our zeros, our vertical asymptote and horizontal asymptote. We'll graph those first. So we have a 0 at positive 2, and we're going to have a vertical asymptote at x equals 1. And a horizontal asymptote at y equals 1. Now, the question is where is that hole at in our actual graph? And so if we simplify this expression and cancel out the x minus 3's, we get x minus 2 over x minus 1. So when we actually have our graph, that's what our graph is going to look like, is just that function. It's just that when we put 3 in for x, we're going to find a hole. So let's go ahead and do that. Let's put 3 in for x then, so that we can find out where that hole is. So 3 minus 2 over 3 minus 1 would give us 1/2. So at the point 3, 1/2, we have a hole. So now the nice thing about this is it tells me that the graph has to go through that spot. So that means then that this graph is going to start down here at the negative infinity, come up through my 0 at 2, and then through my hole. Now on the other side, let's see, when we put, we know that the graph is going to go here then, because since it's at negative infinity on the right side of the asymptote, it's going to be at positive infinity on the left side of the asymptote. So we need to, let's draw this correctly though, or approximately. Well, we know there is a y-intercept, and if I look at the y-intercept, that would be when all the values of x are 0, and this simplifies to 6/3 or 2. So we have a y-intercept at 2, so the graph's going to come through that y-intercept and up vertically, and there is our graph for number 14. So we found the 0 at 2, the vertical asymptote at 1, horizontal asymptote at y equals 1, and because we had a common factor of x minus 3, there's a hole at positive 3. And then if I put 3 in for x, I can find that specific spot of that hole, which would be at the point 3, 1/2. And so there's a couple of examples from the homework that you did last. Okay, now we're going to look at lesson 8.5, which is solving rational equations. and inequalities. We're going to focus on the equations part. Rational equation is just like a rational function. The only thing is we're going to set it equal to some value. And so we need to find what that value is. An example of one is here, that the time t in hours that it takes to travel d miles can be determined by using the equation t equals d over r, where r is the average rate of speed. That's one example of a rational equation. To solve a rational equation, the first thing we want to do is get rid of the denominator, because none of you really like to work with fractions, and so we want to eliminate the fraction first of all. And so we're going to multiply everything by the common denominator, or the least common denominator. So in this problem here, we have the equation x minus 18 over x equals 3. And so let's look at all the denominators that we have. So we have x over 1, 18 over x, and 3 over 1. So if I find the common denominator for this problem, it would be x. Since x times 1 is just x, the common denominator would just be x. So what I'm going to do is I want to get rid of that denominator. So I'm going to multiply both sides, everything on both sides, by x. So what we're doing is what we do with one side, we do the other, but we're going to get rid of that fraction right away. So x times x is x squared minus. Now what's going to happen here then is these two x's are going to cancel. Since one's in the numerator and one's in the denominator, they will cancel. And we have 18 and equals 3x. Now we have a quadratic equation. And we've learned all along to solve quadratic equations, the first thing we want to do is get everything on the same side so it's equal to 0. Now, because it would be nice if we could answer this question just by factoring, but if factoring doesn't work, then you could always complete the square or use the quadratic formula if necessary. But in this situation, we can factor it. So we're going to get everything on the same side, so I'm going to subtract 3x from both sides so that it's equal to 0. And so now we want to factor it. So what do I do to factor this problem? So we get x minus 6 times quantity x plus 3 equals 0. So then x is equal to 6 or negative 3. Now it's very important that you check your solutions. Don't assume that your answer is going to be right. Whether that means you do it in your calculator, you do it by actually plugging in the numbers, whatever you do to check to make sure it's right, please make sure that you check it. So here with this problem, we can put in 6. So we've got 6 minus 18 divided by 6, and that equals 3. And negative 3 minus 18 divided by negative 3 equals positive 3 also. So I checked them both, and they worked, and so I'm good to go there. So make sure you check your answers, whether it's plugging it into your calculator or whether it is actually putting it into the problem and finding the answer. You got your calculator, you might as well use it. Okay. Now, sometimes when we're solving rational equations, we end up with extraneous solutions. And so that's especially the reason why We need to always check our answers to make sure they're correct. So let's go ahead and look at our first one here. And here we have situation 5x over x minus 2 equals 3x plus 4 over x minus 2. Now, in this situation, we have both of our denominators are the same on both sides of the equal sign. So we could then use that same property that we did when we were doing logarithms and exponential equations, like when we had the same base like that. Since these are the same, then that means that these two things are just going to be equal to each other. Now, the thing we have to look for, though, when we're doing this is we have this wonderful denominator here, x minus 2. And since it's in the denominator, if we get what would make that 0 as an answer, then it would be extraneous, and that part would be no solution. So let's solve this equation. We subtract 3x from both sides. So we get 2x equals 4, so x equals 2. Now if I put 2 back in here for x, the denominator would be equal to 0, and we have an extraneous solution which means that there is no solution to this problem. Can't happen. So make sure you check your answers. So the letter B. Now letter B has the same denominator too, except it has this number, this 2 also in the denominator. So if I was to find the least common denominator in this case, my least common denominator would be, the LCD would be 2 times x minus 8. Because these, the outer ones have x minus 8, so they don't have 2. The inner one has 2 and doesn't have x minus 8. So we want to multiply everything by the least common denominator. So we're going to go ahead and multiply everything by the quantity of 2 times x minus 8. Okay. We're multiplying all 3 parts of the equation by that least common denominator. Now what that does then is it cancels out the x minus 8s here in the first term, cancels out the 2 in the second term, and then the x minus 8 again in the third term. So those are gone. So here's what I'm left with. I'm going to write it all out. I have 2 times 2x minus 5. Okay, that's what's left in the first term, plus x times x minus 8, what's left in the second term, and 11 times 2, what's left on the right-hand side of the equal sign. So now I can distribute and solve this equation. So we have 4x minus 20, minus 10, excuse me, plus x squared minus 8x equals 22. All right, so once again, we're going to have a quadratic equation. And hopefully, once we simplify this equation, get everything on the same side, hopefully it will be something that we can factor. So we have x squared. 4x minus 8x is negative 4x. And negative 10, and we're going to subtract 22 from both sides. And we get minus 32 equals 0. All right, so we check to see if we can factor x minus 8 times x plus 4 equals 0. And now I can tell you that there is an extraneous solution, in this problem because we have the same factor as the denominator in our original equation. So this is going to produce, this x minus 8 is going to produce a 0 of 8, and that won't work because when we put it back into our equation, it gives us 0 in the denominator. So my answer here is going to be that x equals -4. And that would be our solution to that. Okay, so that is solving rational equations. So the big thing is that you want to get rid of the denominator. So you want to multiply by the least common denominator so that you're able to get rid of them. And so let's just look at these two check it out problems. And I'm not going to do them all the way. I just want to set them up. So if we look at letter A, on the left side we have a denominator of x plus 4 and x minus 4. And so if we're going to multiply by the least common denominator, then we need to multiply both sides by x plus 4 and x minus 4. So that would completely cancel out the denominator on the left side and just leave 16. And on the right side, it would cancel out the x minus 4, and we'd have 2 times x plus 4. And then we would work with that. For letter B, our least common denominator would be 6 times x minus 1. So we would multiply everything by that quantity to be able to solve that equation then.